Hey, this is Jody with WeldingTipsAndTricks.com. You're going to think I had too much coffee today the way I'm bouncing around here with this chaotic video, but it all relates to lap joints. I promise. I'll tie it all in. We're going to even do some thick multi-pass lap joints on 4140 and this practical application bearing sleeve. So it's all TIG welding lap joints today. We're starting off with 11 gauge cold rolled steel. No pulse, just straight up DC electrode negative current. And we're just dipping and stepping, and I'm watching that corner of that top piece there, and I'm just nipping it, and I'm also watching down in the bottom corner, making sure I flow metal all the way down in there, and I'm trying to keep the heat kind of to a minimum and trying to be in a rhythm and move the torch the same amount each time and dip the same amount of rod in each time and keep a nice tight arc with about the same angle. Dang, anything else? Yeah. The benefits of TIG welding is stops and restarts. There's a lot less problem than they always say with MIG or stick. And to restart on a lap joint like this, just light up right where you left off or about one ripple behind it, and then increase your amperage with your foot pedal until your puddle gets to be the same size as the crater, and then you just pick up like you left off, keeping that tight arc, and you just keep your rhythm going. If you don't have a foot pedal, if you just got a switch, you're just going to wait for about 2 or 3 seconds until your puddle reaches the same size, and then you're going to take off. So it's pretty simple. You can make lots of stops and starts without having defects and without it looking funny. Just DC welding without pulse like I'm doing here doesn't require a very complicated machine. Those were all done with this very simple little Everlast machine here with high freak start. But if you want to weld aluminum, or you want to do high-speed pulse or pulsing at all, you need to step up your game a little bit, and here's some options for you to be able to do all that. The Miller Dynasty 200DX is shown there with that that yellow thing is the remote control receiving unit for the cordless foot pedal. The Lincoln Invertech V205T is a very good little machine. And the Everlast 210 EXT. All these are around 200 amp machines with very comparable features. The Lincoln's laid out like this with a little diagram stepping you across, and so is the Everlast, very similar to the Lincoln as far as the way it's laid out. And the Miller is a little bit different with straight up touch pads working from left to right. Very simple interface. But the thing you can do with an inverter TIG welder like that on aluminum is you can weld aluminum with a tapered electrode. Here's the Everlast 210 EXT welding 11 gauge aluminum lap joint with the AC balance set to about 80% electrode negative. That allows me to weld with a sharpened electrode and pinpoint the heat. Alright, shifting gears again here. I'm going to set this Invertech here for pulsing on the steel. I set it to 0.7 pulses a second. 40% background current. That's a percentage of the amperage that I'm going to be using. And that's my end amperage there. And post flow set at 10 seconds. Start current set to 10. But as this thing welds, you can see it bounce back and forth from 150 amps all the way back down to about 60, which is 40% of the 150 max. 0.7 seems to be a pretty good number to keep up with feeding, so if you get hung up at all. 1 pulse a second is just a little bit of a struggle to fight to keep it fed in there, especially if you're working around the camera like I am filming here. 0.7 pulses, and it only drops down to, the reason I don't have it dropping down further is I don't want to leave a crater hole in there. And just want to provide a rhythm here and a little effect of the pulsing that gives you that stacked dimes look. You know, who knows if it's really beneficial or not as far as the quality of the weld and the metallurgical aspects and all that kind of stuff. But it is a method, and it's an extra feature, an extra tool in your toolbox to mess around with. And you know, you'll find uses for pulse if you have it. You'll also find that a lot of times you won't want to mess with it. That's been my experience anyway. Here's showing the pulse from a different angle. Actually looks a little cold, looks like it's not quite going into the corner there, but you know, some jobs the main thing is there are some jobs where appearance is the main thing. We're doing some 4140 here now, some 1/2 inch or so thick scrap bar stock there. We're going to do some heavy lap joints now in 4140. 4140 is like chromoly, except it's got more carbon content, and it is used extensively in fixturing because of its strength and hardness, and mainly its dimensional stability. It's cold rolled is a lot cheaper, but it's also a lot of a problem because it warps and you start machining on it and to get flat faces and it moves around because there's stresses build up in it. So 4140 is a lot more stable, dimensionally speaking, when you start machining things after welding. So that's a little cold. I was using about 150 amps with a 1/8 rod. I bumped it up a little bit to somewhere between probably around 170 to 180 and dropped the rod size down to 3/32. And it feeds in there a little smoother and you don't have such a distinct cold chill line on the ripple. And that looks a little nicer, don't you think, than the last one? Now, this is a thick piece of 4140, so sometimes you got to add more weld than you can get in one pass. So I'm coming across here with a second pass. Now you could do this by stacking them in there, but I just chose to take a 1/8 rod and weave over it here and also feed just a little bit of rod in as I go. Again, we're up around probably 170 or 180 amps here. This is using the Everlast 210 EXT. No pulse, no anything. Just using it for its amperage. And that 4140 welds like honey. There are issues about preheat and it hardening and being brittle if you're not careful and everything, but you know, for the sake of just this video, I didn't preheat anything. So here is the practical application that we came in the shop. A bearing sleeve pressed in a big piece of heavy wall tubing. It's a roller, and we heated it up to get a shrink fit. And it went in too far and we had to beat it back out from the other end, but it just needed to be recessed about a 1/4 inch past flush, and so the weld here is such a tight fit after that thing shrunk and cooled off that I didn't want to risk shrinking it anymore with heavy weld, so I just put one pass, again using the Everlast 210 EXT here on this. No pulse, no nothing, probably only about 150 amps, and just trying to get one little nice looking pass in there. And I was walking the cup on that because that thing was so hot from it being preheated, and to make it grow so we could slip that thing in there. There it is with the bearing in there. And here's the single pass side of that 4140 joint, and there is with two passes. It's about a 1/2 inch thick material. Now here's the Miller Dynasty doing a fusion pass on some 11 gauge. Sometimes lap joints don't require filler metal. Sometimes they just need to be pretty and sealed up, and you know, if you got a good tight fit, you don't always have to have filler. Here's the Dynasty 200 doing about 0.7 pulses a second without filler, and I'm actually just resting the cup and scooting it each time because I'm up inside a tube on this particular one. I told you I was going to be bouncing around here, didn't I? There we go. All right, one more thing. I may not be the most interesting man in the world, but I do like me some Dos Equis. Okay? Okay. All right, well, thanks for watching. Visit weldingtipsandtricks.com. Go to the website. If you'll click on the link at the bottom of this video, you'll see more details of amperage and pulse settings.